Bismillahirrahmanirrahim. Welcome to lecture number 5 of Object-Oriented Programming course. In the previous lecture, we have seen overloaded function. Then we have seen how we can overload the constructor of the class. So overloaded function is a function with the same name. You have more than one function with the same name, and to make it different from each other, you either provide the different number of parameters to that function, or the type of the parameter should be different. So constructor overloading is you can have more than one constructor is a class in a class, and then the number of parameter passed to that constructor should be different, and this is called constructor overloading. For example, you can have a constructor with no argument and constructor with 2 argument, 3 argument, or 1 argument. Then we have seen a constant object, constant member function, constant data member, and constant object as function argument. So constant object, when we pass constant object to a function argument, I have shown you a distance example. We pass actually the reference of that object. Today we will see a little bit more detail of the reference object, or the reference C++ reference variables. And then we have seen what is a friend function and this pointer. So friend function is a function of a class that is not a member function, but through that function you can access the private data member or the public data member of that class. And this pointer is a special pointer that is created for each object by the C++ compiler, and when you call any function with that object, this pointer is passed implicitly to that function. In today's lecture we will see reference variable, a simple example. Then I will told you why we pass the object reference and why we make it constant, and then we'll see a little bit more about this pointer, and using this pointer we can make cascading function calls. That is, within one statement we write just one statement and we call multiple functions using that statement. Then dynamic memory allocation, then static class member. These are static functions and static data members. C++ reference variables. C++ references allows you to create a second name for a memory location that you can use to read or modify the original data stored in that location. So you have a single name for a memory location, and how you can have that name. For example, if you declare an integer variable, it will allocate 4 bytes for that integer, for example x, and using x you can access that memory. So the reference variable, if you create a reference variable for that memory location, now you can access the same memory that is allocated for x with that reference variable. The syntax of the reference variable is int, you use ampersand sign, then the name of the reference variable, that is foo over here, and then you assign it with some value. I will show you later what is this value. So this is a reference to an integer. So when a reference is created, you must tell it which variable it will become an alias for. So whenever you declare a reference variable, this is a must condition to tell the name of the variable for which it becomes the second name or alias. So for example, you declare a variable int x, memory will be allocated for x. Then you create a reference variable y and initialize it with the variable x. This means that now y is the alias name for the memory that is associated with the variable x. Now you can access the same memory location using x and y. Then you execute the statement y is equal to 50, then cout x, now 50 will be printed, cout y, again 50 will be printed. So same memory location now can be accessed using 2 variables, that is x and y. So you can see this is the reference variable is actually the second name for the same memory location. So this is a must condition that you must specify. This is a must condition that you must specify int and y is a reference variable. When you create a reference variable, you must initialize it. So this is must thing that you must initialize the reference variable with some variable for which it become a second name, for which it become an alias, right? Reference variable within functions. So function can take reference parameter as well. So consider this program. In this program we have a change function whose prototype is the return value of that function is void, and the parameter type is a reference of integer type, reference of int type, right? And within main function we create a variable x. The memory will be allocated and the value is assigned, that is 10, to that variable. Then cout x, it prints 10 on the screen, and then we call the change function and pass that variable, and in the definition we get this value in a reference variable int and y. So what happened over here, y will become the name for the memory location that is allocated for a variable x. Now within the change function you can access the memory that is allocated for the variable x of the main using y, and the same memory can be accessed using variable name x within main function. So when this statement y is equal to y plus 10 is executed, it is actually y is equal to 10 plus 10 and y is equal to 20. So 20 will be stored in y, it will be stored here like this. Now here the advantage of the reference variable is that it won't allocate any extra memory, any other memory. For example, if we pass this by value, then this ampersand sign won't be there, and 4 bytes of the memory will be allocated for y. If we pass the address of x, then this must be a pointer static y, then still 4 bytes is allocated in the memory for variable y. But y is a reference variable, so no memory will be allocated for y. Instead, y becomes a second name for the memory that is associated with the variable x. That is the advantage. Now let's see the constant object as a function argument. Here we are passing the let's first ignore this constant. For example, this is not a constant, then what happened? Let's see. So then this is distance, and this means that this is an object, reference of an object of type distance, right? So if you pass a reference of an object, the first question is why we passed by reference? Because it saves memory, it is the efficient as compared to pass by value or pass by pointer. If you pass it by pointer, then the 4 bytes will be allocated by the pointer, then you are accessing the object indirectly, that is by using the pointer. Now you pass that object by reference, this means that you are passing the reference of this object, or the reference of that particular object is created in the addDest function, and through that reference addDest function can change the value of the original distance object जो आपने यहाँ पे पास किया होगा इस function को call करते वक्त. So to avoid this change, you make this parameter as a constant parameter. This means that this const makes the distance reference variable as a constant. This means that addDistance is not able to change the value of this parameter, and this constant is there to make this addDest function constant function. This means that the addDest function won't be able to change the value of the private data member of the invoking object. This is the function definition. I hope now it will be clear to you that why we use a reference variable, why we use a reference object, constant reference object when passing an object to a function. This is because to avoid that function to change the value of the private data member of that referenced object, right? Now let's see something more about static, arrow operator and dot operator with structures, right? So let's consider this part of the program in which we have the definition of a student structure. We have seen this definition a lot of time in the previous programming course. And then in the main function we create a pointer. First we create a pointer. So for that pointer is pointer p, and its type is struct student. This means that this pointer points to a memory location where you have a variable of struct student type, or the memory that is allocated for a struct student variable, or a memory where you store struct student. And then you create a variable of type struct student. Now it has two parts. The first part contains the ID. So when s.id is equal to 10 is executed, the third statement is executed, 10 will be assigned to this location and 3.7 will be assigned to this location. Now the address of this structure is 7550, we assume it, and then we assign this address to a pointer p. This means that we create a connection, we can access the structure through this pointer. Now what are the different mechanisms to access it? We can write p arrow operator id. This means that p arrow operator means that it will bring you over here, then what you are going to access, id. So you write id, or you can write CGPA. So the output of this cout statement is 10 3.75, or you can write static p. Static p is value at 7550. So this is the value at address 7550. The value at address 7550 is id and CGPA. Now what values you are going to access? The first you mention id, the second you mention CGPA, right? So again the output is 10 and 3.75, right? So again let's explain this cout second statement once again. Static p means static 7550, and static is value at address 7550. That value is basically a combination value. This is a combination of id and CGPA, right? So when you reach here with static p, now what value you are going to access? You use dot operator, dot id or dot CGPA, right? This is a third cout statement. This is very simple. You can access the value of that structure using the variable name, that is s.id and s.cgpa. The output is the same. You can also access the value like this, and s. Now and s is same like p, right? So address of the structure. So and s arrow operator id, it's same like p arrow operator id. So the output is 10 and 3.75. And this is actually same as static p when you write static p. So and s is the address. So value at address, you reach there, then you access id and CGPA. The output is this. So the output is same in all these conditions, all the situations. These are the different mechanism to access the value of that structure using the pointer to a structure or using the simple structure variable. Now let's once again see the implicit and explicit use of this pointer that we have seen in the previous lecture. So we make this function constant function because that function, print function, won't change the value of the private data member. Now this first cout statement, we are accessing the private data member, and here the compiler will implicitly use this pointer to access this value, right? Because this pointer is a pointer to, so whenever you create an object, this pointer for that object is created by the C++ compiler, right? So whether you create an object of distance class, test class, or count class, or employee class, or student class, whatever class, whenever you create an object of that class, a pointer, a constant pointer is created by a C++ compiler, and the name of that pointer is this, right? So when you call a function by using the object of that class, any member function of that class, what happens is that this pointer that points to that invoking object of the member function will be implicitly passed to that function, right? Now you can use it explicitly or implicitly, right? So in the first cout we directly access the value of x. Here the pointer is actually, this pointer is actually used implicitly, but here we explicitly mention that we are using this pointer to access the value of x. You can write this arrow operator x, or you can dereference the pointer by static this, then you use dot x, right? Let's go to the program and we change it so that it can pause. Compile and execute it. Okay, now you can see you can access directly. This is the implicit use of this pointer, and here is the explicit use of this pointer. Now cascading function calls using this pointer. Cascading means you're calling one function, then another function, then another function, then another function, and so on. In cascaded member function calls, invoked multiple functions in the same statement. For example, we have an object of class T, class time, that is the name of the object is T. So we can have this cascading function calls. So T dot set hours, we are passing the value 18, dot set minute, we are passing the value 30, dot set second, we are passing the value 22, right? Now in this case, the first statement that is executed, so dot operator is basically the associativity of the dot operator is from left to right. So we will solve the leftmost call first. So this will be solved. Now set hour object is basically invoked by the set hour member function is invoked by the object T. And when this is invoked, it will set the hours of the object T. So T जो object है उस पे 3 private data member है, these are hour, minute and second. So set hour will set the hours of object T, and then it will return the reference of T, reference of object T. Now using that reference, the other function is called, right? That is set minute. Set minute is called with the object, with the reference of the object T. So it will set the minute of object T. Then it will return the reference of object T, and with that reference another set second function is called, and set second function will set the minute of the object T and also return the reference, right? So this is the cascading function call, and with the one statement you call a multiple functions. And how this is possible? This is possible basically using by using these pointers. So this is a time class. Okay, so we have a set time function. Now the return type of this function is a reference time and reference of an object time, reference of an object of class time, right? So set hour also return a reference of an object of time class, and set minute and set seconds also return the reference of the object of time class. Now here just ignore this scope resolution operator and time, just ignore this thing, scope resolution operator and this time, right? So what happened when the set hour function is called? If you remember this function call here, set hour dot set minute dot set second, what happened over here is you pass the some value that is 18 to that function. Now check this value, if that value lies within the range, yes it is, it assign this value to the hours. Hour is the private data member of the invoking object, that is T. Now what it returns? It returns static this. Now what is static this? Static this is basically the memory that is the memory जिस memory location पर आपके पास time class का object T पड़ा है, वो memory location return करेगा, और basically उस memory location का reference return होगा, because here we have time T, right? So and then just remember it, why we have static T over here. Let me explain this. So let's say this is the memory that is allocated for the object T. I'm sorry for the writing. So in this memory we have basically 3 parts. The first part is for the let's say hours, then minutes, and then seconds, right? Now whenever this object is created, another 4 byte of the memory is allocated, and that contains, and this memory, this is basically for this pointer, right? And this contains this memory location contains the address of this memory location. So this means that this memory points to this memory location, right? Now this is the pointer. Now this pointer is basically a pointer to the object T of class time, right? So why we are returning the reference over here? So this is the pointer. Now what I said over here, that if you return static this, it is returned by reference, that is mentioned over here. Why we return static this, why not this? But the difference is that if you return this, then this means that you are returning the reference of a pointer, right? Because this is the pointer, this is just a pointer. So when you write static this, at static this you have an object, this object, right? This is static this. To understand this, you have to be very clear with the concept of pointer. What if we write static with it or without static? So without static means that, for example, the address over here, let's say that if this address is 751, that is the address of, let's say, this memory location. So if I return this, then this means that I'm returning a pointer, and the reference of this pointer is returned. So incompatible type, return type, right? Because this is a pointer, and here you are saying that you are returning, here you are saying that you are returning the reference, right? So यहाँ पर आप बता रहे हैं कि आप ऑब्जेक्ट का रेफरेंस रिटर्न करेंगे, and if you return this without static, then you are returning basically the pointer, not the object. But when you put a static over here, then this means that you are returning the object actually. So आप ये object फिर return कर रहे हैं basically, right? So जब object आएगा तो object return किस फॉर्म में होगा? Object का reference return होगा, right? और जब object का reference return होगा, जब यहाँ पे ऑब्जेक्ट का रेफरेंस रिटर्न होगा, नाउ यू कैन कॉल द अदर फंक्शन, तो आप दूसरा फंक्शन कॉल कर सकते हैं. और सेम थिंग इज हैपनिंग ओवर हियर, दैट यू आर checking the value, validating the value that if the minute is within the range. Yes, if it is, then you assign it to the minute. If it is not, you assign 0, right? Then you return static this. So static this is basically the object of time class, that is T object, right? And you are returning it, the reference of that object. You mention it over here, right? And same is the case with the seconds as well. I hope now this is clear to you. Let's go through again once again. So this is our cascading function call using this pointer internally. So why does the technique of returning static this as a reference work? Why not this? Right? So now it is very clear that we have to return actually the object by reference, not the pointer by reference. The dot operator associate from left to right. So first it will call the function t dot set hour, from it start from the left side, then the reference of that call will be returned. That call return the reference of the object time, and then the second function set minute will be called, and so on. First it evaluates t dot set hour, that is 18, then returns the reference to the object t. The remaining expression is then interpreted as t dot set minute. T dot set minute call execute and return the reference to the object t. Then it will solve t dot set seconds 22, right? Let's go and see the program. So this is the program. We also return the reference. So let me remove it first. Okay, so here you can see we are also returning the reference in the set time function, right? We'll see where we can use it. So we can use it to print the time. So first this statement will be executed, then we print the time t, then we change the value of time by calling the set time function, that is you pass three values, hour, minute and second, to that function, and then this function set the values and return the reference of the object t. The same जिस तरह से set hour, set minute और set second reference return कर रहे हैं object का, इसी तरह से set time भी reference return कर रहे हैं, and using that reference it prints the value, and here the values printed are 20, 20, 20, right? The first place the values are 18, 30 and 22. Let's compile and execute this program. Now you can see 18, 30 and 22 and 20, 20 and 20, right? So this is how we can make a cascading function call. That is, within one statement we can call multiple functions actually. Now let's come to the topic of dynamic memory management. That is very important topic. C++ enables programmer to control the allocation and deallocation of memory in a program for any built-in or user-defined types. It is performed, dynamic memory management is performed using a new and delete operator, while in C we use a malloc function to allocate dynamic memory and we use free function to deallocate that memory. Here we will be using new operator to allocate memory dynamically, and we will use delete operator to delete that memory location that is allocated dynamically, that is at execution time. For example, in employee class we have a name that is a character array, so it has some specific size. So employee class mein we have two names, if I remember, the first name and the last name, and the size of these two names are 25 bytes long, or it could be 15 bytes long. So there is some kind of limitation. For example, if the name is too long that it won't come in the 25 byte, it might be possible, or if the name is too short, that rest of the bytes are just wasted, right? So what is the better approach? So through dynamic memory we can allocate array space same as the number of character in the name. So if the number of name is very long, then we allocate the memory accordingly to store all the character of that name. If the name is very short, we also allocate the memory accordingly to store all the character and make sure that rest of the characters are not, rest of the bytes are not wasted. For example, in case of we have a fixed array of 25 size, then if the name is we want to store is, if let's say if it is Ali, then it will take ALI and then the null character, just the 4 characters, and the rest of the 21 characters are just wasted. That means it is not used by any other variables in the program, right? So to avoid this kind of situation, we can use dynamic memory allocation so that we can allocate array space same as the number of character present in the name. So dynamically allocating memory in this fashion causes an array to be created in the free store that is called heap. So जो भी memory allocate होगी वो RAM में एक special area है heap, that is called free store, वहाँ पर create होगी. Heap is a region of a memory assigned to each program for storing objects created at execution time. So जो भी during the execution object create होंगे वो heap area में create होंगे. So heap is a special area in the memory that is used to store the objects or variables or the memory that is allocated during the execution of the program. That means that you don't know about this allocation at the compile time, right? So if you write int x, so that is not dynamic memory allocation, that is static. You know at a compile time that you have to allocate 4 bytes for x, right? Once the memory is allocated in the free store, pointer points to the first byte of that allocated area. So what the new operator will do, it allocates the memory, whatever size we tell it, and then it returns a pointer. Now using that pointer we can access that memory location in the free store. So after using that memory location, this memory may be returned to the heap by using a delete operator. So delete operator we can use to return that memory to the heap so that it can be used by any further program. Dynamic memory, let's see some of the basic types. So C++ allows you to provide an initializer for a newly created fundamental type variable. For example, we can allocate a memory for a floating point value, and then we have a pointer that points to that memory location. Now this is the type of the pointer. With new operator it creates a memory of type double, and the value stored in that memory is 3.14159, right? So first it allocates a memory for a double, that is 8 byte, and store the value 3.14159. So pointers के लिए 4 byte allocate हो जाएंगे, 3.14159 इसके लिए 8 bytes allocate हो जाएंगे, and let's say the address, starting address of that memory location is 704. Now this 704 will be assigned to a pointer. This means that now this pointer points to this memory location, right? Now using that pointer you can access this value 3.14159. So that is dynamic memory allocation for a basic type. Similarly, you can allocate memory for int or character or float. This is how you can delete this memory location, delete PTR. So it will delete the memory, this memory that is allocated for a value 3.14159. And this memory is actually allocated at a special portion that is called free store or heap, that is used basically for the memory of the objects or the any basic types that is allocated during the execution of the program, that is allocated dynamically. Dynamic memory using array or dynamic memory allocated for dynamic array. That means you are going to make an array whose size you don't know at compile time. So new operator can be used to allocate arrays dynamically. So this is the this is how you can make an integer array of size 5. So integer pointer grade array points to a memory location where you can store 5 integers, right? So new int new will create a memory for integer whose size is 5. So this is the square bracket. So you can store 5 integers value in that newly created memory. So this is newly created memory. You can store 5 integer value, and the starting address is, let's assume that it is 704, and then it creates a pointer grade array that takes 4 bytes in memory and assign this 704 address to that pointer. This means that now this pointer points to the memory location where you can store 4 integer values. So it points to the first byte of this memory location. ठीक है, इस memory location की जो first byte है जिसका address 704 है इसको point करेगा. ठीक है. Next integer value will be 708 byte, right? Because there are 4 bytes in between. Because integer takes 4 bytes, so next integer value will be 4 byte away, right? And to delete this memory location, you write delete array symbol grade array, right? This is an array symbol. There's no need to mention the size of this array. It automatically guesses how much memory it is allocated for that array in the heap area. Now let's see some of the simple example programs. We will write example program 1 in which we have a character pointer. We allocate memory dynamically using new operator to that character pointer, and then write a string and display it, and then delete the dynamic memory using delete operator. In example program 2, we have a structure definition. We allocate dynamic memory for that structure, write string and display structure contents, and then delete that dynamic memory. Now let's go and write the program. Okay, so we have a character pointer over here, and then we create a memory. This is dynamic creation of the memory, right? This means that create a memory dynamically where we can store character, and how many characters? 10 characters. So if I write 100 over here, it can store 100 characters, right? And then we use string copy function to copy that string in this location, right? Or we can ask the user to input that string. For example, we can write cout, enter name, cin, get line, cin, comma p, that is the address where to store it. Let's check it out whether it works or not. I don't know exactly what is the function called, so we can use just cin like this, call it, and the name is, let's say, Ahmed. Display the name perfectly fine. So let me compile it and run it again. 72. So enter name, let's say we enter the name Ahmed Ali and display that name, right? So this is how you can dynamically allocate the arrays, and this is how you can delete it basically, right? And deletion is must thing, right? Because if you don't delete it and create it again and again and again and again, then the area of the heap will be filled up. Okay, we have to write the example program too as well, so let's go to that. So let me first comment out this thing and write the definition of a structure. Struct student comma integer ID float C GPA. This is the definition of a structure, and then we can write a main function. Okay, now we are going to create a memory for that structure, right? So we have a struct student pointer. Now P is equal to new struct student that's it. P arrow operator ID is equal to 10. P arrow operator C I think this is not the syntax, maybe. Let me check out. I have the example below. And okay, new student, just write like this. Five system pause. Let's compile it. Okay, now let's print out these values. See out P arrow operator ID and P arrow operator C GPA. So 10 is the ID and CGPA is 3.75, right? So if you write so what if I write struct over here, then so it is perfectly fine. So you said that okay, reserve a memory for one element of struct student. So it will allocate 8 byte because the size of this structure is 8 byte of the memory, and return an address that is stored in a pointer P, right? Okay, we forget to delete it. Delete P. Although इससे कोई फर्क नहीं पड़ा execution पे, लेकिन but still you delete the memory that you allocate dynamically, right? That is a good habit. Now we have seen the simple program. Now we come to the dynamic memory for the objects. How we can allocate dynamic memory for the objects. So consider the following declaration and statement. So we create a pointer. Now time PTR is a pointer that points to an object of type time, or we can say that this pointer points to the memory location where the object of time is stored. ठीक है, जहाँ पे time class का object store होगा उस memory location को time PTR point करेगा. Now the second statement is we are creating new time. So we are creating a memory for an object time. So object के लिए memory allocate हो जाएगी, and the address of that memory location will be in time PTR. Now we can use arrow operator with time PTR to access the private data member of that object. So this is time PTR and this is object. So सबसे पहले time PTR के लिए 4 byte allocate हो जाएंगे. Now new time. So new time means to create an object of time class. So this is an object of time class. It initializes all the private data member with 0, and then this is the pointer that is set. So new operator return the memory where it allocates the object of time class, and that address will be stored in time pointer. And we use delete function, delete operator, to delete that memory location, that is time delete time PTR. So you write delete and then the name of the pointer. Let's go to the program. So this is the program. Now to call the function, you use arrow operator with this pointer. Now this is a pointer to an object, right? A pointer to an object, एक object की तरफ pointer है, और जो एक ऐसा pointer जो एक object को point कर रहा है. Now you use arrow operator with that pointer to call any of the functions, any of the member function of the class, right? So let me compile this program and execute it. Now this is 0, 0, 0. Let's say why it is 0, 0. So here it invokes a constructor that is a default constructor 0, 0, 0, right? So what if I write over here 18, 16, 45, then it invokes the same constructor, but now it initializes it with value that I have provided, not with 0, 0, 0, right? Let's run it again. Now we get the value 18, 16 and 45, right? Let's invoke this print time function through another mechanism, that is static time PTR. Let's see whether it works. Dot print time. Let me comment out this thing, compile and execute. Yes, it works fine. Now you can see basically these two are the same thing. This is a pointer. Time PTR is a pointer to a memory location where the object is stored. Now you can go to that memory using the arrow operator or using the static operator. If you use a static operator, then you use a dot to call a function, and if you directly want to go to that memory location, you use an arrow operator, right? And then we delete this memory location. Okay. So this is how you can create a dynamic memory for an object. There is one more example that I want to show you. Let's go to the program, time program, and let's make another class. Let me comment out all this thing and write another class, that is employee class. Okay, that I discussed you when we are at the start of discussing dynamic memory. Employee class, and that has the private data member, a character pointer, static static name, let's say. Okay, that is only the private data member, and the public function public. Now here I will tell you the usage of destructor that I told you when we are on the destructor topic, that destructor are basically used to deallocate the memory that is allocated for that object, right? So what we can do here is employee so we pass it some string. Now we have to calculate the size of that string and store this value accordingly, right? Let's say format it a little bit. Okay, so let's calculate the size. Int len gth is equal to strlen string length s. Calculate the size of s, right? and before that let's include string class so that we can use the string functions. Okay, so यहाँ पर जब भी constructors का call करेंगे हम, we pass it a string, an address of a string, right? So what we do is we check the size of that string जिसको s point कर रहा है, right? And then we will allocate the memory accordingly, right? And then we will assign the address of that memory location to this name, right? So name is equal to new character. Let me check the syntax. It's one slide. Okay, this is the syntax of the dynamically creating an array, new, type, and number of values you want to store, right? Now let's go to the program. So this is our program is here, character, and how many character we want to store? This is length plus 1. So plus 1 is for the null character, right? Then we use string copy function to copy the content of s in name. So to copy the content of s, the string in this name, because अब name के लिए name एक pointer है, उसके लिए हमने memory allocate कर दी है, और कितनी memory allocate की उसके लिए हमने we allocate length plus 1 byte, right? So now we copy it, and yeah, that's it. So this is the constructor. Okay, then we have another function, let's say print function. Now what this function do is it will print name is equal to, let's say, name, end line. Then we have a destructor, employee, and destructor is used to delete this array, that is name, right? So let me see out over here, see out. Destructor is called, end line, and here we can write is okay, write the same statement, just copy it and paste it over here. Constructor is called, right? Now let's write the function void. Let's see, the name of the function is ABC, and we create an object of employee class. Let's say E is the object, and we pass it the value name, let's say Ahmed Ali, right? Then we call a function E dot print, that's it. And then this function exit, when this function exit, the destructor will be called, and the control will be transferred back to the main function from where we call this function, right? So we call this function ABC, and then there's a system pause statement. Now you see the purpose of the destructor, it automatically deallocates the memory that is allocated dynamically in the constructor. So अब यहाँ पर आप देख सकते हैं, यहाँ पर हमें कुछ we don't have any idea whether we are using, whether the dynamic memory allocation is used in this class or not, right? So it automatically handles all the things. Let's compile it. Okay, let's say display is the name of the function. Name of the function. Public display with no type. Okay, void display okay, now it is fine. So if I run this program, so it first show me the message constructor is called, then it display the name Ahmed Ali. It dynamically allocate the memory, copy the content of that string into that memory, and store the pointer address of that memory, dynamic memory, in a private data member of the object E, and that object private data member is a pointer whose name is name and type is character. And then the function exit. When the function exit, the object is destroyed because that object is created inside that ABC function. And then the destructor is called. It print the message, delete the memory, and returns the control back to the main function. Right? Now this is the real. You can see the real use of the destructor comes. Right? So it deallocates the memory that is allocated dynamically, automatically. It do all these things. So here, when we writing the main function or the other function that uses this class, we have no idea whether there is a dynamic memory allocation is used in the class or not. Okay, presentation again and objects. And now let's come to the another topic that is called composition, that is object as a member of a class. So an alarm clock object needs to know when it is supposed to sound an alarm, right? This means that, so why not include a time object as a member of a alarm clock class? So we have a class whose name is alarm clock, and then we can have another object as a data member of that class, and that object is of class time. It stores hours, minute, and seconds value. So it needs to know the time, that when to start ringing the alarm. So this is referred as has a relationship. An alarm clock class has an object of time class. We will see how an object's constructor can pass argument to member object constructor in the example, because when you invoke the constructor of alarm class, it will create an object of time class, and then this means that when the object of time class is created, it will call the constructor of time class as well. Example program, let's say we have a date class, date.h, and this includes month, day, month, and year, that is the date, and an employee class that has the employee data and the two object of the date class. The employee, these are the birthday and the hire date object. So the name of the object is birthday, type who belongs to the class date, and hire date who is the object of date class. And then we have the source file. So these two are the header file. So date.h contains the definition of the date class, employee.h contains the definition of the employee class, and it also contains, within that definition, it has the two object of the date class. And then we have the source file, that is emp.cpp, and here we create an object of employee class, and the name of the object is manager, right? So in the memory, so memory is allocated for the object manager, and the employee class contains the first name and last name as a string, and then the two object of the date class, that is the birthday and the hire date. So these are the two object of the date class that are the part of the manager object, right? So this is called the composition, because now we can say that employee has a date, employee has a birthday, employee has a hire date. So this is has a relationship, right? Let's see the example program. So this is the file name is source emp, and we have included the file employee.h. Now if you remember, when we are on the topic writing the specifying the definition of a class in a separate file and the main function in the separate file, so what we did is we put the definition in the header file. So here this file is date.h. this is, let me write, date.h file, and this file contains just the definition of a date function, right? So a month, day, year. This is a constructor. Default date is set, and then we are checking print function, and then a destructor, right? It just display the message. Destructor just display the message date object destroy for date, and then print the date, right? So this is the date.h file, and we include this file in employee.h file. So this is employee.h file. So there is no need to mention to include IOStream file and other file, because they are already included. They are already included in date.h file. So if you go to the date.h file, it is already included IOStream, string file, and using namespace std. So there is no need to write the same thing in employee.h file. Okay. Now that is very interesting thing. So the parameters to the employee are basically the pointer to a string, a constant pointer to a string, and a pointer to a string, that is first name, last name, and then a reference of an object of date, and that is a constant. Basically you cannot modify it, right? So this is a reference. Date of birth is a reference of a date object, and that is a constant reference. This means that within employee function here, it is not possible to change the value of date of birth, right? So what you do is you just call the basically the constructor of this object, right? So this is also the constant object, right? So when this statement is executed, it basically calls the constructor of the date class, right? It calls the constructor, and the same thing happens over here. This is in the initializer list. These are the parameters, the string, and the reference of the date object, reference of the date object, right? And then in the initializer list, we initialized birth date, that is the private data member of the employee class whose type is date, who is the object of date class, and it is a constant object. And similarly, hire date is also the constant object, because date of birth, once it is set, it cannot be changed. So anything that is constant, it should be initialized in the initializer list of that class, right, of the constructor. So similarly, we initialize it over here in the initializer list, because they both are the constant data member, right? So this is called the composition. You have created an object of a date class within the definition of the employee class. This is composition, and because these are the constant, so these must be initialized in the initializer list of the constructor of employee class. So this is the initializer list where you are initializing these values, and this is the date class, right? And then we use a string copy function to copy the value of first in the first name and the last in the last name. So first name and the last name are the character array of size 25, right? You can have a character pointer over here that I have shown you previously in the previous example, and then you can dynamic check the size of the, calculate the size of the first and calculate the size of the last, right? And then you dynamically allocate the memory and assign the address of that memory to the first name and the last name, and then we copy the string from the first to that dynamically memory and copy the string from the last to that dynamic memory, right? Now the question is that why this is constant. These are the constant because just to avoid that employee function is not able to change the original string by using this pointer, ठीक है? So वो इस पॉइंटर के साथ अगर यहाँ पे कांस्टेंट नहीं लिखा होगा ये कांस्टेंट, दिस मीन्स दैट आई कैन चेंज द स्ट्रिंग कंटेंट ऑफ द ओरिजिनल स्ट्रिंग विद इन द एम्प्लॉय फंक्शन. मैं यहाँ पर इसकी कंटेंट चेंज कर सकता हूँ, बट इफ इट इज कांस्टेंट आई कैन नॉट चेंज इट, राइट? Then display the message first name last name. Then there's a print function. Now this function is a constant function because it won't change the private data member of that class. That's it. Now let's come to the, so we include this employee.header function over here, and this is our class, this is our file that contains the main function. So what we did is we create an object of date class, right? There's one thing left, that is this thing. So this is a reference of a date class, and this is the object of date class, right? This is the object of date class and reference of a date class. So we will see what is this function called. This is actually a copy constructor, right? We will see in detail what is this in the next, maybe in the next lecture. So in the employee, in the our source underscore emp.cpp file, we include employee.h file. So when we include employee.h file, this means that we also include date.h file, because employee.h file में हमने date.h file को include किया था, and we also include iostream and string and using namespace std, because ये तीनों चीजें हमने date.h file में include की थी, right? Then we create two objects, that is birth and hire, whose type is date. We initialize it with some value, and then we create an object of manager. This is the first name, the last name, and then this is the objects we are passing, and these two objects are the object of date class, right? And in the employee class we are getting it as a constant reference, right? Now this is the constant and this is the reference of the date object, so we are getting here as a reference variable, and that's why we make it constant, so that we are not able to change the value of that object, original value of that object, using this employee constructor, right? Otherwise, if that is not constant, then it is possible to change the value of that referenced object or reference variable from that function, जिस function को आप वो pass करें as a reference. Then we print those values, see out the message, and then we again create an object of date, that is invalid month. It must display the message that the month is invalid. Let's compile it and execute it. Now you can see the first place, date object constructor for date. This is date of birth, this is date of birth, and then this is date of hire. So in the date, whenever the constructor is called, it says the date object constructor for date, it prints the date, right? And then date object constructor for date, this is the hire date. The employee object constructor Bob Blue, so Bob Blue hired, this is the hire date, this is the birthday, it prints all the thing. Then test date constructor with invalid values, so invalid month 14 set to 1. So in the source file you set the month 14 and that is invalid, right? Then it again So this is for the month, and for the day we haven't write anything for the day, so we can write the same thing checking for the day as well in the date class. So इसको आप खुद से लिख सकते हैं यहाँ पर date class में कि हम तो सिर्फ month को भी चेक करते हैं, यहाँ पर आप day के लिए भी बना सकते हैं और year के लिए भी इसको चेक कर सकते हैं for example. ठीक है. So this is all about the composition, that we can create an object of one class in the definition of an other class, and this relationship is called has a relationship. So that is all for the lecture today. Let me summarize the things that we have go through in this lecture. We have seen first the example of the reference variable in C++, and what is the advantage of reference variable, why we pass the reference object to the member function of a class, and why we make that reference object the constant, right? And then we comes to the dynamic memory allocation. We use a new operator to allocate memory either to the basic data type or to array or to the object, and we use the delete operator to delete that dynamic memory. And whenever the memory is allocated, it is basically allocated to a free space or to a free store in the memory, that is special area, that is also called the heap. And that is place is actually reserved for all the objects, for all the variables, for all the arrays, that is for which the memory is allocated during the execution or dynamically in the program. And then we have, in the last we have seen what is a composition, and what the composition is actually has a relationship. It simply means that we create an object of one class in the definition of another class. Thank you very much for the listening. See you in the next lecture. Allah Hafiz.